We use an empirical approach that is based on these concepts. First, it relates crop attributes with potential yields. So let's say this is extracted from a document from USDA, how they calculate crop estimates. Actually, it's a different concept because they will be doing regional estimations. And so there's a lot of, they rely a lot on surveys and other methodological aspects. In this case, we're just discussing how we would approach this at a field level. So it's a different concept. But the thing they have in common is that they also use, in those surveys, they use yield forecast variables. So they identify in corn what would be the aspects that determine yield variables. On soybeans, the same. In cotton and wheat, we're going to be using something very similar. They mentioned fertile spikelets and grains per head. In our case, we'll be using grains per spikes and spikes per square meter. So in essence, they're the same. There's an article there that we'll send the just for information purposes on understanding USDA crop forecast and their methodology, and so that's where it's extracted from. There's a chapter on yield forecast. It's a little bit mixed with surveys and how they target on certain farmers, and then they verify these variables. So number one, we're going to try to estimate these two variables related with wheat yield, grains per spikes and spikes per square meter. This also gives us the idea that this can be used in other crops besides wheat. So if we can have a way of determining these variables by relating it with NDVI or other vegetation indexes, that could work. Then the second step is to establish a correlation between these attributes and observed NDVI. That's the index we're going to use at some key stages in the crop. And then if there's a strong correlation, then just by knowing the NDVI values, we can infer the grains per spikes or spikes per square meter variables, and then estimate yields for the whole field. So it's a pretty straightforward, simple method. It relies on these assumptions. We can estimate yield by knowing these variables, and we can relate imagery index, such as the NDVI, with these variables. So if we can do those things, then we can estimate yields. There are sorry, I was, for some reason it was on pause. So that's what I was just talking about. The estimation approach is based on three principles. One, it's defining which attributes we're going to use for yield estimation, then establishing a relationship between NDVI and those attributes, and then making this inferring a complete map with those attributes, and then calculate the yield estimate. We'll see this in detail, but the idea what I wanted to mention is that this is something that could be applicable to other crops because there are other variables that are related with yield, and if we can establish a relationship between imagery and the crops, then we can estimate yields for the whole field. Okay.